Everything we've talked about so far has led us to the topic of camera matching and match moving, which are cornerstone techniques in visual effects, and most shots wouldn't be possible without them. But it's also a big new topic and you need your clarity, so this is a good time to take a break. Now, to put elements together, they need to be shot from the same angle, or station point as we call it. The station point changes the perspective rendering, so being very low or very high renders a different perspective than being level. Being close by also gives a different perspective than being far away, which has a flatter perspective. We're obviously changing the zoom between these two shots, but we're only doing it to get the far away shot bigger in the frame, because all we care about is the camera's position relative to the actor. So if you're shooting an element on green screen and this is the correct station point, it's okay to zoom in to use your entire resolution. The perspective rendering is the same, we're just Xeroxing it bigger to use the entire negative. The whole point then is that to composite elements together, the station points have to match in both shots. And some examples of doing it wrong are first of all to be high up in this shot, but putting her into a level shot. Or we might be level on her, but put her into a low shot. We also might be very close here, giving a warped perspective, but be very far away here, so they again don't match. Matching station points is primarily about matching the height, because it quickly shows if you're off. Onset compositing can help get the angle right, but you're much better off if you simply make a habit of measuring the camera height for every shot you ever do. You simply write it on a piece of paper and roll 2 seconds of film. Then it's easy to shoot other plates from the same height. If we're doing scaling, like if we want to put her on this table, we first shoot the element and note the camera height. Then we simply divide it by 10 and shoot the table at 8.7 inches. So they match without problem. The tilt doesn't matter as much between the shots because it doesn't change the perspective rendering, so it just has to be in the ballpark. Matching the distance to the subject is also important, especially when we're close, because the perspective is so pronounced. When we get 20 or 30 feet back, there's really no point in going further back because it wouldn't look much different. So if you're shooting a green screen element that will be placed on a mountaintop, you don't actually have to be a mile away. 20 feet will do it. If we want to put 3D into a scene, we also have to match the 3D camera to the live action camera. This is done so that the 3D objects will have the same perspective rendering as the live action, and also to help 3D interact with the live action. For example, if this stick needs to cast a shadow, we can then build a 3D ground that matches the live action ground. And then we can cast shadows that bend the same way and in the right places. On a lock shot, you typically just eyeball the 3D camera by loading up the shot as a background in the 3D software. And then the goal is to see if we can fudge a camera position and focal length that makes the grid line up. This is difficult, but not impossible. But everything in this chapter so far has assumed a lock camera. if there's any camera movement in a plate, we have to somehow copy that exact camera move in the other plate. We don't really consider pan tilt to be an actual camera movement because the perspective doesn't change enough to matter. So to put in this car, all we have to do is eyeball a good angle in 3D. Then in Fusion, we 2D track a feature. And when we attach the car to the tracker, we have for all intents and purposes copied the camera move. You could actually create an entire matte painting in Photoshop as an overlay and just track it in. Another way is to shoot an oversized background plate at a very high resolution. Then we can do all our paintwork or insert 3D graphics. And then we can simply scan through the image, which is the same as a nodal pan. But an actual physically moving camera is a totally different ballgame because the movement in one plate has to be matched in the other. If both plates are live action, there's only one way, which is motion control. Then we program a single camera move once and repeat it on several locations. But if we have a live action plate and we want to put 3D into it, we have to somehow copy the live action camera move in 3D. But that's actually not so simple. If we, for example, wanted to put this car into the parking lot, we could first of all try to use a 2D tracker. Then we track a rock in the middle, and then attach the car. But it's very obvious that the car's angle isn't changing, so this doesn't work. We have to match the actual perspective change. So as a second attempt, let's instead load up the clip as a background in 3D. And then let's try to match the camera move by adjusting the 3D camera and setting keyframes. Looking just at the car, it seems like it could work. But when we composite it, we're not even close. Suddenly, it's painfully clear that a real camera move is far too complex to be copied by hand, and the car is skidding and sliding all over the place. We haven't tried very hard, but the thing is that it doesn't matter if we spent a month on it, it will never work. There's just too much detail we're not aware of. But there is a technology that can solve this, which is called match moving. Match moving is able to read a shot and extract the exact camera move in 3D. Then anything we create in 3D can be shot the exact same way. And when we put them together, it's a little bit like magic, because the 3D looks like it's really standing there. This is such an important technology that it's part of almost everything we're talking about from now on.